So today we're going to be applying proportional reasoning to solve a lot of different word problems. Now I am going to do some of these problems differently than the way the book does it because I think that the way the book does some of these problems is a little confusing. So I really do suggest either printing these out or writing notes and not just following along in your book. Write down the way I'm doing it as well. Okay, so the ratio of collectible cards Deshawn owns to cards that Stephanie owns is 5-2. Stephanie has 36 cards. How will the ratio of Deshawn's cards to Stephanie's cards change if they both sell half their cards? Explain. Okay, so what I'm going to do is I'm going to start off with setting up a proportion. So 5/2, okay, that's our ratio. And Deshawn goes on top and Stephanie goes on bottom because Deshawn... so the ratio is Deshawn owns to, the ratio of collectible cards Deshawn owns to cards that Stephanie owns is 5-2. So Deshawn on top, and then we're going to put Stephanie here, equals, Stephanie has 36 cards. Since Stephanie has 36 cards, that's going to go on the bottom with where Stephanie is. Okay, then I'm going to put an X here because we don't know what that is. So now we need to find out how many cards Deshawn owns if Stephanie owns 36. So we're going to multiply. 2 times x is 2x equals 5 times 36 is 180. Then we divide by 2, and we're going to get x equals 90. So now Deshawn, this is Deshawn up here, has 90 cards, and then Stephanie has 36. So now what I'm going to do is I'm going to read again. How will the ratio of Deshawn's cards to Stephanie's cards change if they both sell half their cards? Well, if they both sell half of their cards, Deshawn has 90 and he's selling half of his cards. He now has 45 because half of 90 is 45. If Stephanie has 36 cards and she sells half her cards, she now has 18 cards. So now it's 45/18. Remember, our original ratio is 5/2. So we have to figure out if 5/2 is the same thing as 45/18 because it's saying how will the ratio change? Let's see if it changes. So we're going to take 45/18. We're going to reduce this. So we can reduce this by dividing by 9 in the numerator and the denominator. 45 divided by 9 is 5. 18 divided by 9 is 2. So did the ratio change? No. Still 5-2, okay? So the ratio will not change. Okay, try it. Let's do this one together. Don't worry about doing this one on your own and checking. Just follow along with me. After selling half of their card collections, Deshawn and Stephanie each buy 9 new cards. What is the ratio of the number of cards Deshawn has to the number Stephanie has? Okay, so what we're going to do for this, so remember, when they sold half of their cards, we had 45/18 if we refer back to the last problem. Okay, so Deshawn, because remember, he started with 90, he sold half his cards, now he has 45. And then this is Stephanie. She started with 36. She sold half her cards. Now she has 18. Now, if they are each buying 9 new cards, then we're going to add 9 to these values. So 45 plus 9, Deshawn now has 54 cards. And then Stephanie, 18 plus 9 is 27. So what is the ratio? Let's reduce this. Okay, so 54/27. I know that 9 goes into both of these numbers, so I'm going to divide by 9. Divide by 9. 54 divided by 9 is 6, and 27 divided by 9 is 3. This reduces again to 2/1, right? Because divide by 3, divide by 3, that's 2/1. So now our new ratio is 3/1. The convince me says, why did the ratio stay the same in the example but change in the try? So remember, for the last one the ratio was the same, but now we have a new ratio as 2/1 instead of 5/2. The reason the ratio changed is because the ratio did not stay the same because we specifically added 9 to each quantity. If you add a number to each quantity instead of multiplying it, it's going to create a different ratio. So that's why, it's because we added. Example 2. Recognize when to use proportional reasoning. So this is actually not a proportional relationship, so we can't set up a proportion or anything like that for this. Martin is 6 years old when his sister Cassandra is 3 years old. How old will Martin be when Cassandra is 6 years old? So I'm actually going to set up a table for this. We're going to have Martin's age, and then we're going to have Cassandra's age. Okay, so if Martin is 6 years old when his sister is 3, so now if Martin is 7, right, if he ages 1 year, Cassandra will be 4, right, because she's also going to age 1 year. When he turns 8, she'll be 5. When he turns 9, she'll be 6. So it says, how old will Martin be when Cassandra is 6 years old? So when Cassandra is 6 years old, Martin will be 9 years old. Okay? Next one, example 3. A video streaming service charged Brian $143.84 for full year access. So remember, full year, that's 12 months. Brian thinks he was not charged the correct amount. What should Brian say when he calls customer service? Write an equation to represent the situation. So the rate is $8.99 per month. Shows that here, it's $8.99 per month. So we can create the equation. Remember, y equals kx, so it's y equals 8.99x. X stands for the number of months. So let's figure out how much he should be paying for a full year. That would be 12 months, right? So we're doing 8.99 times 12. And when you do that, you get y equals $107.88. But he was charged $143.84. So no, he wasn't charged the right amount. So no, he wasn't charged the right amount. What should Brian say when he calls customer service? Well, $8.99 per month times 12 months, I should have been charged this much. Okay? All right, try it. For this one, a florist makes bouquets that include 50 white flowers and 7 red flowers. If the florist orders 1,050 white flowers and 140 red flowers, there will be leftover flowers. How can the florist adjust the order so there are no leftover flowers? Okay, so there's like a few different ways to do this, but what I would do is I would first think, okay, 50 over 7. So we're going to put white flowers on top, and then we're going to put the red flowers on the bottom. And then I'm going to look at this and just see if it's a proportional relationship. So I'm going to put, once again, white flowers on top, and then the red flowers on the bottom. So I'm noticing here, to get from 7 to 140, I would have to multiply by 20, right? I would have to multiply by 20. So now if I multiply the top by 20, well, 50 times 20 is not 1,050. 50 times 20 is actually 1,000. So how can the florist adjust the order so there are no leftover flowers? She should order, I don't know why I put a comma there. She should order 1,000 white flowers, because that'll keep the proportion the same. Let's do the do you know how questions together today. A recipe calls for 15 ounces of flour for every 8 ounces of milk. Is the relationship between ounces of flour and ounces of milk proportional? Yes. You can write the equation y equals 15 over 8x, right, because 15 over 8, to represent the situation, which is a proportional relationship. If you use 15 ounces of milk, how much flour should you use? I want to set up a proportion for this. I really like doing proportions. I find them very easy. I think it's the easiest way to do these. So 15 over 8 is what I'm starting with, because that's what it gave us, 15 over 8. So flour is on top and then milk is on the bottom. 15 ounces of milk, so milk has to go with the milk. So we're going to put 15 down here. We don't know how much flour there is right now, so we'll call it x. Now you multiply. 15 times 15 equals 8 times x. So 8 times x is 8x. And 15 times 15 is 225. Now we need to divide by 8. Divide by 8. X equals, if you make this into a mixed number, 8 goes into 225 28 times with 1 left over. So 28 and 1/8 ounce. Or if you put it in the calculator, it's 28.125 ounces. So either answer is okay. I do prefer fraction form though. Okay. A food packaging company makes a popular fruit cocktail. To ensure a good mixture of fruit, there are 3 cherry halves for every 8 white grapes in a jar. An inspector notices that one jar has 12 cherry halves and 20 white grapes. What can be done to fix the error? Okay, so first I'm just gonna kind of like set this up as a proportion, and let's just see if it's proportional. So 3 over 8, we're putting cherries on top, and then we're putting the grapes on the bottom. Let's see if it equals 12 over 20. Let's see if that makes sense. I just put 20 over 20. I apologize. Okay, long day. 3rd day of home instruction. We got this. All right. So what I'm seeing here is I'm first thinking, okay, to get from 3 to 12, I have to multiply by 4. Now, to get from 8 to 20, well, that doesn't work. So if I multiply by 4 on the bottom, this should really be 24. So there's a few different things you could say. What I would say is that the inspector can add 4 more white grapes. So the new ratio is 12 over 24. So instead of 12 over 20, instead of 12 cherry halves to the 20 white grapes, it's now going to be 24 white grapes. So we're adding 4 here. So instead of 20, it's 24. And which is equivalent to 3/8. So now it's equivalent to that. Make sense? All right, so you're going to do on-course questions today instead of the practice and problem solving. It's all posted in Google Classroom. Let me know if you have any questions, and have a good day.